Okay. Hello students, welcome to Fun Scholar. So today we are going to discuss the topic of exponents, which will be beneficial for both ICSE and CBSE students. So let's start. So this is exponents. So in to study exponent, we have to know about the base and power. So basically exponents is something which we write in the head position of any number or any variable. Okay, so if I write like this, and I hope you all seen numbers or letters or variable be written like this. So this is known as the power and this is known as the base. So this is the basic structure of exponents or powers with the base. Okay, so and one thing you must remember this, that don't get confused by seeing like this. Power of every time powers stays in the head position, and this is not a power. You may confront this kind of equation or this kind of letters or variable. These are more evident in physics or chemistry. So these are suffix. This is not power. Okay. So this is just a fun fact I have told you. Okay. So let's start the actual chapter. So now that we all already know that, I mean maybe we have all studied it in the lower classes like in 6 or in 7. So that 10 to the power 1 means 10, just like this, and 10 square or 10 to the power 2 means 10 into 10, which means 100. This goes for the all kind of numbers. If I write 2 to the power 5, so then it will mean that 2 into 2 into 2 into 2 into 2. That means we have to multiply 2 with 2 5 times. Okay, so this is the power. So if you said that each exponent equals the number of zeros in each product, you are right. Okay, so you can see a pattern here, just like I am putting 1 in the head position of 10. So that means 1 0. In 10 square it means 2 0. In 10 to the power cube it's 3 zeros. In 10 to the power 4 it's 4 zeros. Okay, so from this we get to know that it's been easier if we calculate numbers having 0. If I write 20 square, then this will be 20 into 20 and the answer will be 400, where there will be 2 zeros and 2 square 4. Okay, these are all the fun facts, or this will be beneficial for solving the mental maths. Okay, so now we have to know that why we are studying this, or what is the uses of this topic particularly. That area and volume, exponents are used to calculate areas like square units and volumes like cube units. Okay, so this is an evident use of exponents in our daily life, that if you have to measure the area of this rectangle or the area of this square, if you have to measure the area, so we have to calculate the length and the breadth. Okay, or for this square, maybe it's not looking like a square, but think it as a square. So it has 4 sides, and we know that 4 sides of a square are equal. So the formula will be side into side, or we can say that side square. Okay, so you can see that a power is coming in when we are calculating the area of any square, the power of 2 is coming. Okay, so this is an example that why we are studying this topic specifically, or where is the usage of this topic. So we use exponents or powers to calculate the area or volume. Okay, so it goes for the square, and if I talk about the rectangle, so in rectangle we usually calculate length into breadth to calculate the area of any rectangle. So in this calculation, length is length or centimeter, whose unit is, and breadth is also a length. Okay, but breadth usually is a little bit shorter than the length. Okay, but this is a type of length also. So because length is coming 2 times, so that's why we multiply centimeter into centimeter or meter into meter 2 times. So that's why we write like this, centimeter square or meter square. So area is a option, or area is a use of power and exponents. Okay, the same goes for volume as well. Okay, when we calculate the volume of any kind of shape, just like you can see this is a square, and we know that if I want to find the area of a square, though it is not a square, this is a cube, the three-dimensional display of any kind of square. So it's a cube, but you can think just this part of it. Okay, so this will be a square. Why? Because all side of this square is same. If I want to calculate the area of this square, so side into side will be the area. But if I want to calculate the volume of this cube, we know that volume, we can't take volume from a 2-dimensional image. We have to take the 3-dimensional image to calculate the volume. Okay, if I kind of pour something into it, just think it as a hollow shape, and if I pour something into it, so how can we measure that how much liquid we are pouring into it? So then we have to find the volume of this shape. Okay, and as I told that we are thinking this as a hollow shape. Okay, you can find there are so many things which used to display in any kind of shops, and they are like cube. They are cube in shape, glass, and we can see just like aquarium. Aquariums are the best examples. There are also cuboid or cube-like structured aquarium you can see in the fish market or the fish shops. Okay, so they pour water into that aquarium, and so to know that how much water will it take to fulfill the cube, so they need volume. Okay, to find the volume we need length, breadth, and also the height. So technically there are 3 types of length we are counting in. Okay, one is length, the second one is breadth, and the third one will be height. So there are 3 types of length, so that's why it will be length cube. Okay, that's why the unit of volume usually becomes like centimeter cube or meter cube or decimeter cube. Okay, so these are the real life examples where we use the exponents or power. There is another real life use of exponent. Okay, we know that Yes. So I have written a number. Okay. So this is usually scientists tell that this is the speed of light. Okay, 3 lakhs miles per second. Okay. But if we want to form it or transfer it into meter per second or centimeters per second, so scientists usually write this like 3 into 10 to the power 8 or 3 into 10 to the power 10. This is an evident use of using power or exponents to showcase anything's speed or velocity in any kind of form. Okay, in science the power or exponent has multiple uses. Okay. Okay, so it's like this. Computing large numbers, exponents are used to represent very large numbers easily. Okay, now we will go to the next slide. So now we will have to see a video. Okay, so let's see a video, power of 10 part 1. This has total 3 parts. I'm showcasing you the videos and then I will explain it like in few lines, and then we will go to the next slide. Okay. what did we have learned from this video? That we have to, if I write this number, so what we have to do, we have to just split the zeros. So here we can see there are 4 zeros. Okay, so 5 is being multiplied with 10,000. So the answer will be 50,000. So we can write 5 into 10 and there are 4 zeros. So we can count them and write it like this. Okay, so this is the standard form. So anything which has powers of 10 can be expressed like this. Okay. So now we have also some videos, but I am not letting you watch those videos right now because they are in the decimal form also, fractional form also. So you will go further and come again later in those videos and watch those videos and then solve some questions. Okay, so now come to the basic points. Just like I told it earlier that 10, here 10 is the base and 2 is the exponent, and here the whole, this whole equation, or rather not equation, the whole term will be called as the power of 10. Okay. So then we will go further. So let us use this introduction as like, if n is a whole number and a is any number, then a to the power n means multiplication of a n times. Okay. Here a is a whole number. Okay, think it as 5, and if I put, n is a whole number here. Okay, n is a whole number, I am taking it as 5, and a is any number. Okay, be it natural number, be it real number, or be it any kind of number. So I am taking 5 to the power 5. So that means it will be 5 into 5 into 5 into 5 into 5. Now you may have any question that why I am taking a as any number and n is a whole number. Okay, maybe this question arises in your mind. So I am telling you, then if I take like this 2 and in the power is 0.5, okay, or this can be also written as like this, 2 to the power 1 by 2. Okay, so these are also numbers, but if I write like this, so then the concept of this 2 into 2 or 2 into 3, 2 into 2 won't get satisfied. This rule won't get satisfied if I take power of half instead of them. Okay, so why they are not satisfying this rule? Okay, so we will learn it further. So currently we have to take the whole number as the power. Okay, where a will be the base and n will be the power. And just like they have also written 5 into 5 into 5 here 7 times. So the base is becoming, base is now 5 and the index or the power will be 7. Okay, this same goes for, okay, just like I have told that a is any number. If I take 2 by 5 and in their power we are taking 2. So then the answer will be 2 by 5 into 2 by 5. Yes, they are satisfying this rule. Okay, if I have to take the power, this power must have been a whole number. Okay, and it doesn't matter if I am taking a or the base as any kind of number, be it fraction, be it natural number, be it negative number like negative integers. If I am taking -2 as the base and I am taking 7 as their power, this will also mean that multiplication of -2 7 times. Okay, just like this. Okay, so you can see that they have taken 2 to the power 6, where they have multiplied 2 6 times, and here they have taken 2 to the power 3 and 5 to the power 2. So they have multiplied 2 3 times and 5 2 times, which is giving the value 200. Okay. Now we will go to the next slide. Here you have to test yourself. Okay, take a pause of this video and try to do it yourself, but I will do it currently. Okay, so here they have given us a equals to 3 and b equals to 2. We have to find the value of a to the power b and b to the power a. So just write value of a, that is 3, and the value of b, that is 2, plus value of b, that is 2, and value of a will be 3. Three square will be 9 and 2 to the power cube will be 8. So the answer will be 70. The same goes for like this or these as well. Okay. It will be 3 to the power 3 plus 2 to the power 2. So the answer will be 3 to the power 3 means 27 and 2 to the power 2 means 4. Okay. So 27 plus 4 will be 31. If you have any difficulties understanding them, so then I am writing this by breaking it down, like 3 square can be written as 3 into 3 and 2 cube can be written as 2 into 2 into 2. Okay, so it will be 9 plus 8 and the answer will be 70. Okay, these also can be true, can be done for these as well, and I am giving this up to you whether you have to write an extra line or not. Okay, you can do this like this. Just to do it like this, you just have to remember the tables. Okay, the table of 3 3s are 9 and 9 3s are 27. Okay, said they have just done the same. You can just put a bracket before and after them, just to understand it a little better. Okay, so that you don't make any mistakes for counting this plus and minus sign. Plus sign doesn't give any trouble, but the minus sign gives. Okay, so just be careful while solving this kind of problems. So the next one, what is the product law of exponents? Okay, this one is another video, so let's watch the video and then I am coming it again. Product law.
Now that we have studied the basics of exponents, let's understand problem asks us to express this in exponential form. 3 raised to 7 multiplied by 3 raised to 14. Since these two are multiplied and have the same base, we can use the product law. Why is it called the product law? It's simply because it deals with the product of two numbers. Using the product law, we can write this as 3 raised to 7 plus 14, which gives us 3 raised to 21. If we did not have the product law, we would have to write 21 threes in our notebooks to arrive at this final answer. Let's get the next problem. 5 raised to 78 plus 5 raised to 24. Using the product law, this can be written as 5 raised to 78 plus 24, which equals 5 raised to 102. Correct? Wrong. Yes, the base is same, but notice that we have an addition sign here, and product law can be used only for multiplication or product as the name says, not for any other operation. What about 5 raised to 4 multiplied by 6 raised to 4? We cannot use the product law here since the base is different. Base here is 5 and the base here is 6. It doesn't matter if the exponents are the same. If the base is different, the product law cannot be used. But can only two numbers be multiplied using the product law? Not necessarily. If we have an expression like 4 raised to 3 multiplied by 4 raised to 2 multiplied by 4 raised to 5, we can use the product law. Same base and product. So this can be written as 4 raised to 3 plus 2 plus 5, which equals 4 raised to 10. So the product law says that while multiplying numbers with the same base and their exponents,
Okay, so what did we learn from this video? That the product law. If I explain this to you, like if a to the power m into a to the power n, this will give us a to the power m plus n. And if I explain this with examples, if 2 to the power 5 into 2 to the power 7, so the answer will be 2 to the power 5 plus 7, 2 to the power 12. Okay. So in short, this is the product law of exponents. Let's see the next slide. Okay, what is the quotient law of exponent? Okay, before coming to the video, we will just try to solve some questions that what we have learned from the video. Okay. So do these ones first. Write the following numbers using exponents. So if I want to write this number as exponent, so what we have to do, we have to just first count the zeros. Here are 1, 2, 3, 4, 5, 6, 6 zeros. So it will be 10 to the power 6 and the answer will be 1. We can write it like this, or it can be stayed like this only. Okay. 1 by 1000. So 1000 will be 1 by 10 to the power 3. Because 1000 has 3 zeros. Okay. 64. So if you want to see any number that whose power is it, you have to memorize the table, or you can do just factorization to check whose power are these. So if we have to factorize 64, so this is an even number, so, and we know that every even number can be factorized or division can be divisible by 2. So this will be 32. this will be 16, this will be 8, 2, 2. Okay, so 1, 2, 3, 4, 5, 6. So 64 means 2 to the power 6. Okay, we can also do this thing with 4. Okay, so there are 3 4s. So 64 can also be written as like 4 to the power 3. Okay. So and 8 to 1 can also be done like this. Okay. If I tell you to count the 9's table, so we know that 9 9s are 81. So it will be 9 square. And if I tell you that express 81 as 3's power, so we have to just divide 81 with 3. Okay, so 81 can be written as 3 to the power 4 as well. Okay, so these 4 questions been done. Now simple. Okay, no, we don't have any question right now. Okay, we will solve some more questions after covering the topic of topic division and something more. Okay, so first of all, before going to the video, let's take a glance of the laws of the exponents again. Okay, the first law, so we have just learned this law. Okay, we have just learned this law, and now we are going to see the quotient law. But before going to the video, this law will be the same, I mean same as the multiplication law. Okay, if we divide anything like a to the power n by a to the power n, just if we have division, the operation division operation there, so there will be subtraction between the numerator and denominator. Okay, so let's watch the video first, and then I will let you clear all the things.
In the previous video, we saw how product law was applied to a product of two numbers with the same base.
so we also learned the power law of exponents for division, the product law and the quotient law as well. Okay, so what we have learned from the quotient law, if I summarize it, like if I write this and divide by this, so the answer will be this. So the base have to be the similar, and m and n will be their power. But one thing we must remember, that m or n shouldn't be the 0. Okay, we haven't talked about it, that if anything, the power of any whole number or any number is 0, so that means the value of that exponents will be, or that term will be 1. Okay, we haven't talked it earlier, but maybe we will in some times or in the further slides. So let's go to the next slide. Okay, the power law of exponent. Okay, we are coming it a bit later. So what is the power law? Okay, for any 0 number, we just watched a video, so I am not against the video, but we will see it a few times later. Let us do some actual practice problems, and then we will come to the video. Okay, so in short, all the power laws, so we have summarized it here, that if a to the power, if we write like this, I mean the nth power, the nth root of a can be expressed as like this. If I write it like any examples, if I write 27 to the power 3, or the nth root of 27 will be like this. We know that it has a value, that 3, the 3 cube means 27, so the cube root of 27 will be 3. So these also can be written like this. Got it? Okay, the same goes for like this. If I write five to the power cube and make cube root of that number, so the answer will be 5 to the power cube multiplied by 1 by cube, 1 by 3. Okay, 3 and 3 will get eliminated and the answer will be 5. And we already know that 5 to the power cube gives us 125, and the cube root of 125 becomes 5. Okay, so this is all the power rules of exponents. We already seen this formula here. So now we will go to the next slide. Okay. So now this one is test yourself. We have to do the sum. Okay. Okay, so a computer's memory is represented in terms of power of 2 if 1 TB is or terabyte is means 2 to the power 40 bytes. Okay, so how many bytes are in the 4 TB? Okay, so we know that, so it will be like 4 into 2 to the power 40 bytes. Okay, so we already know that 4 can be written like this, 2 to the power 2, and we already have 2 to the power 40. So though the base are the common, so it will be 2 plus 40, 2 to the power 2 plus 40, and the answer will be 2 to the power 42 bytes. Okay, so this will be the answer. You can see it. Okay, and they just so they have just put the real value of the bytes. We know that 1 terabyte means what, 1024 gigabytes maybe. Okay, so they just put the real value of the bytes. Okay, so and let's go to the next one. What is the value of minus 1 to the power 10111? Okay, so this one is quite interesting problem, that if minus 2 to the power 3 and minus 2 to the power 4, okay, they both have base as minus 2, and we know that a base can be any number can become a base, but power has to be a whole number till now. Okay, so we know that, so it will be like minus 2 and minus 2. We don't write these two notations together, so that's why I am keeping it in brackets. Okay, so the answer will be 8, and the sign will be minus minus plus plus minus minus, so it will be minus 8. Okay, so and for this case it will be we know that 2 to the power 4 means 16, and minus minus plus minus minus plus 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 plus, so the sign will be plus. So one thing we have learned from these two examples, that the even value or the odd value of the power gives the sign, if there is minus, gives the sign minus, and the even value of minus gives the sign as plus. Okay, so but what about 1 which is being given in the problem, that what is for 1? Okay, so if we know that 1 to the power cube is 1 squared is 1 to the power 100 will also be 1, because that means 1 has to be multiplied with 1 multiple times. Okay, be it 3 times, 2 times, 100 times, and so many times. But what about the sign? Here the sign is minus. So if I am taking minus 1 as the base and putting a power which is a odd number, which is a even number, and again which is a odd number, so it will give me the value 1, but the sign will get changed. For even number it will be plus, and for odd number it will be minus. Okay, so here we have minus 1, and as power we have 10,111, and we know that 111 is a odd number because the last number is odd, so the whole number will be odd, and we have it in the minus sign, so it will be 1 by minus 1 to the power 10111. Okay, and the answer will be 1 by minus 1. Okay, because this is an odd number and minus 1 will be like minus 1. Okay, got it. The next one, what is the value of 1 to the power minus 10111? Okay, so this one will be 1 by 1 to the power 10111, and it will be 1, so the answer will be 1. Okay, this is also like the same process. If a is any non-zero number, what is the value of a to the power 0? I have talked it about a few times earlier, that a to the power 0 will give us the value of 1. Okay, be it any number, be it 2 to the power 0, 3 to the power 0, 100 to the power 0, all the values will be 1. Okay, so this is like an universal truth, that a to the power 0, the value of a to the power 0 will be 1, and a is any number. Okay. See, these are the solutions. Okay, now we have to test ourselves. So you can do it by yourself. Okay, just pause the video and you can do it just by yourself. Okay, the answer will be this. They have just flipped the number 1 by 3 and it has power minus 3. So if we flip it, so then it will become 3 by 1 to the power 3 plus 4 by 1 to the power 3 plus minus 5 by 1 to the power 3. And we know that in the denominator position or in the down position, 1 doesn't have any kind of value, so they write all this down here and solved it. Okay. Okay, this one is quite interesting sum. So let's solve this. We have x to the power m plus n into x to the power n plus l into x to the power l plus m, and in down position we have 3 terms and they are squared. So if we write like this, okay, you guys can do it with me. So x to the power m into x to the power n, this term can be written as like this. Okay, multiplied by this term also can be broken down like this. Okay, this one, and in the down position there will be x to the power m into x to the power n into x to the power n and its square. Okay, if x is so we can see that we have 2x to the power m, 2x to the power n and 2x to the power l. So these all can be written as like this, and the down position will be same like this. Okay, so it also has a square. So, and if I put the square inside them, so it will also be like, okay, now you don't have to do this, we will have to we just need to keep 2 outside and these two will be like same. See, these two are the same term. So the same term will get cancelled and the answer will be 1. Okay, this one is quite interesting one. I just like moderate to difficult problems. Okay, see this, yes, they have exactly done it like this. Okay, we just break it down in a like more evenly, but they reduce the steps and solved it. Okay, so this one is also a very easy one. Okay, I hope the answer you haven't seen it yet, but I have. They didn't answer it like quite very well. So let's do this. 2 to the power 3 whole square, and because value of x is 2 to the power 3, we have write it down here, and the power of x is square, so we also write it down. Okay, so y is equals to 2 to the power 4 and its power will be 3, and by the power of z is 2 to the power 5 and the power is 4, so we have wrote it down here. So as per the power law, we know these two will get multiplied, so it will be 2 to the power 6 into, it will be 2 to the power 12 and it will be 2 to the power 20. Okay, and we know these two powers will get added, so it will give us 2 to the power 18, and in down position it will give us 2 to the power 20, and the answer will be 2 to the power 2. That means 1 by 4 will be the answer. Okay. Oh, the solution part I have done already in the previous one. Okay, so now these are going to be your homework. Okay, to solve the question, you have to solve this question. And thank you students for this lecture, and I hope I have covered all the topics. Okay, and now you have to do is to practice. Okay, goodbye.